Okay, well, welcome back to what is starting to be quite a lengthy topic, really. Anyway, we've had a bit of a look at series circuits, and you've watched a video there of about an hour in length. This one hopefully is a little bit short. It's about 20 minutes or 15 minutes long, and we're trying to get across some information in relation to parallel circuits. And indeed, we're really going to jump a little bit ahead here, and we're going to talk about series and parallel circuits throughout this video. So anyway, straight out of topic 9 of your LMS, and this one is an introduction to series and parallel circuits, resistances in series parallel circuits, Ohm's law in series parallel circuits, and power in series parallel circuits. And as we look at a typical diagram here of a series circuit, that being the first light bulb that you can see, and that light bulb is in series with the supply, and the second light bulb is in series with the supply, but in parallel with the first. So the two light bulbs, light bulb 1 and 2 if you like, are in parallel with each other, and you can see the three light bulbs that are definitely in series at the end there. So a series parallel circuit with three branches, one branch having three lamps in series. Okay, the next part of this video is going to explain how we can simplify this circuit and reduce it down to one resistor, which will then allow us to find the current in that circuit. And once we know the current, we can start to pull it apart and move the current around and divide it as we need to, and start to work out voltage drops across each of the resistors and so forth. So look, get yourself a pen and a paper, write this question down. It's a pretty standard question. Hopefully by the end of this video, and certainly the number 2 as well, we should be able to sort these sorts of problems out quite easily, and I actually hope you start to enjoy the game of chess. R3, so let me get my pen working. Here we go, R3 and R4. Because we need to simplify this circuit, we're trying to get it down to one resistor. Okay, so let's start here. Let's start by redrawing this circuit here by saying the RT of this resistor here, we could change that resistor there, would simply be the additions of these two resistors. Because in a series circuit, which these two resistors are in series, because I guess the definition of how do you know if something is in series or parallel, well, these two, R3 and R4, are in series because the current here flows constantly through R3 and constantly through R4. So the current in this circuit is constant. So that then says that these two resistors are in series. Okay? Alright, so if they're in series, RT equals R1 plus R2, which we covered elsewhere, which is equal to 150 plus 450, which is equal to 150 plus 500, it's 600 ohms. Okay, so these, just let's rub this out here a second, could be replaced with this, because what we're trying to do is simplify this circuit. This resistor here and here could be replaced by a resistor of 600 ohms. So let's, how do we do this? What's the best way of doing this, Tom? Let's draw it down here. There is a 600 ohm resistor. Okay, cool. That's those two there. Okay, cool. And we know that this one here is R2, that's 400 ohms. Okay. So just working on this section of the circuit now, this we realise here that there is current that flows that way, and there is current that flows that way. So this current here might be, let's say it was 10 amps. Well, you know, some of it's going to flow this way and some of it's going to flow that way. And we don't know what that is unless we calculate it and so forth, but it won't be the same. But realise that, that current there and that current there coming back will equal, so the current there and the current here will rejoin here and here. So that will be 10 amps. So we have 10 amps flowing from the supply, we'll have 10 amps returning to the supply, but the currents, you know, they split and do certain things, and that's this game of chess that we talk about. So all good, no problem. So we're trying to work out, what we're trying to work out here is, and there's one particular concept I'm trying to get to, is how do we work out, how do we simplify these two resistors into one resistor? We just want to put them into one resistor, all right? So, and the way we do that, and I'm pretty sure I covered this a little bit in class, but let me redo it here. If I was to use the word sum, if we sum these, and I don't mean adding, you know, I don't mean adding, I mean summing. This looks really tricky, but you will see the formula RT in a parallel circuit is 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Now that's one way of working it out. Look, I don't like that formula. It's difficult and it's hard and it's but you will see it drawn like that, and good on you. If you want to use that one, that's fine. It's exactly the same as this. 1 on RT equals 1 on R1 plus 1 on R2, etc. Okay, and really what we're saying is that if you use your calculator, and on your calculator there's an x to the minus 1 button, all right, and if this resistor here is 400 ohms, you simply put into your calculator 400 and you press the 1 on X button, and it will convert it into this part of the formula. All right, and then you do 600 and you 1 on exit, and that will give you this part of the formula. And then all we do then is add them, and then you will end up with a very small number, and then most students forget to use the 1 on X button for this section here. Could probably explain that a fair bit better, but I'm pretty sure we went through most of that in class. So when I say we simply need to sum these two resistors, that means that you go 400 1 on X plus 600 1 on X, add those, and then you press the 1 on X button, and your answer, your RT answer for this will come out slightly less than the lowest resistance. So the answer that you should get will be something like 300 ohms. Okay, so please practice that on your calculator. That what you do is, I'll just go through it again. If you want to sum these two resistors, you would go 400 1 on X equals, and that'll be a small number, plus 600 1 on X. You add them together, and then 1 on X to get your final answer. Okay. Each calculator is slightly different. This is one of the reasons why I stress upon you that you must get your own calculator, because you'll figure it out on your calculator, and then you'll go and use a different calculator and it'll be a different thing. But anyway, so we sum these parallel resistors together and we come up with a single resistor. Okay, so having said that, let's sort of move along a little bit and see if we can't start to solve this a little bit. This is equal to 100 ohms. I would suggest that this resistor here, these two resistors here, are 400, 500 is 600 ohms. This one's 400 ohms. This one is 60 ohms. Okay. Number 2, I'm going to suggest that we can put a resistor in here, and we're going to simplify this circuit now, and I'm going to say to you that that is approximately 300 ohms. Haven't actually worked that out in the calculator, but anyway. So that's number 2, and then the next one is that now we simply have a series circuit because the current in this circuit is constant. So the resistor value total RT, because now this is a series circuit, because the resistance is because the current is constant. T equals R1 plus R2 plus R3. Okay, so that's equal to 460 ohms. That is how we can simplify a circuit, quite a complicated circuit here, into a 460 ohm resistor. And electrically, the circuit at the top here, this top circuit here, electrically it is exactly the same as having one resistor equaling 460 ohms. Okay, let's see if I can explain this to you on a calculator itself. A calculator. We had a problem in the PowerPoint presentation that you're looking at the moment, and it is simply saying that we need to add 150 ohms plus 450 ohms together. That is those two resistors in series. So, RT equals R1 plus R2. So 150 plus 450 is equal to 600 ohms. So those two resistors can get simplified into one 600 ohm resistor. That resistor is in parallel with a 400 ohm resistor. And I'm trying to get you to realise that we can simply just sum those together, and the formula for that is 1 on RT is equal to 1 on R1 plus 1 on R2. All sounds a lot. Okay, it's really simple if you're using a calculator, and this is what I want to try and get to. So if we go 400 and we use the 1, so 400, and we use the 1 on X button, that button there looks like that there on your calculator, 1 on X, done. And then we add, okay, the 600, so 600, okay, and it's all backwards and everything, and you're looking in the mirror, okay, good on you, 600, and then we 1 on X again, okay, and we equals that, it gives you a very small number, okay? It's because you still need to do one more 1 on x. And the answer is 240. And I appreciate it's coming up backwards on your screen. So that's what I'm trying to say. 1 on RT is equal to 1 on R1 plus 1 on R2, which is the same as saying 400 1 on x plus 600 1 on x, add them together, 1 on x, 250 is the answer. Hopefully that is clear.